So we are given this graph. It is g of x and h of x, and they don't tell you which one is which. So the first thing we have to do is figure out which one of them is which. Here's what I would do. One of them starts at 0, 1, and the other starts at 0, what is that, 4? So I would plug in a 0 to each of them and just see which one comes out to 1 and which one comes out to 4. So if you plug 0 in here, cosine of 0 is 1. 1 times 3 is 3, and then 3 minus 2 is 1. So this one is the one that's starting at 1. So this one's going to be g of x. And then if you want to just double check, if you plug in 0 here, you're going to have 2 times 1, which is 2. 6 minus 2 is 4. So that one's going to start at 4. So the upper one is h of x, and the lower one is g of x. All right, so let me get out another piece of paper here. Find the area of R. All right, so that is going to be integral from 0 to 2, and then it's upper graph minus lower graph. So h of x minus g of x dx. Now this is non-calculator, so you can't just put that in your calculator and get an answer. We're going to have to actually do this by hand. So part A is the part that has a lot of work. Now the first thing I'm going to do is kind of adjust h of x here real quick, because this is probably what most of you would do. I'm going to multiply this out. It'll make it easier to do the antiderivative. So if you multiply this out, x minus 1 squared, that'll be x squared minus 2x plus 1. And then I'm going to distribute the negative 2's through that. And then I'm going to go ahead and set this up here. So this will be integral 0 to 2. H of x is this one. So 6 minus 2x squared plus 4x minus 2. And then we want to subtract g of x. So that's going to be, I'm going to subtract the whole thing, like both of these terms. So it's going to be minus negative 2. That'll be plus 2. And then minus 3 cosine of pi over 2x dx. So these 2's are going to cancel. You were probably like, why didn't she combine these? Because I've done this problem before and I knew they were going to cancel. So the plus 2 and the minus 2 cancel out. And now we're ready to do the antiderivative. So again, it was upper graph minus lower graph. I just kind of did some algebra there to, multiply that out, distribute, combine like terms, cancel these. And now we're going to do the antiderivative. So this will be 6x minus 2/3 x cubed plus 2x squared. So that's for those three terms. Minus, now over here, this is going to be a u substitution. You would have to let u equal that inside part, like the guts of the problem. The derivative is just going to be pi over 2, and you would adjust it with a 2 over pi. So instead of writing the whole thing out, and I'm doing this to show you every step, if you have a pi over 2 in there, if you know that you're going to need to just adjust it with a 2 over pi, just multiply a 2 over pi out front and then go about the rest of the problem. All right, antiderivative of cosine is sine. So this would be 3 sine of pi over 2x. And then this whole thing is such that 0 to 2. So again, if you had like a 1/5 in there, you would just need to multiply a 5 out front. Like that's your adjustment. So you can write all this out if you want, but if it's a real simple thing like that, just put the reciprocal out front and then you'll be good to go. All right, so upper boundary minus lower boundary. If we plug in 2, 6 times 2 is 12. And remember, you don't have to simplify any of this because it's free response. 2 cubed is 8 times 2 is 16, so that'll be 16/3. But you can write it as 2/3 times 2 cubed. I just don't want to do all that writing. All right, 2 squared is 4, double that is 8, minus 2 over pi times 3 sine of, now if you plug in 2, the 2's are going to cancel, so sine of pi. You don't need to evaluate sine of pi. You can just leave it like that. Now sine of pi is 0, so technically you didn't even need to write this whole thing at all, but you can just leave it because it's free response. And then minus lower boundary, if you plug in 0 for all these x's, that's just going to be 0. And sine of 0 is also 0, so that would just be minus nothing. Now be careful with the trig though. Sine of 0 is 0, but cosine of 0 is 1. So you can't just automatically assume if you plugging in 0 that everything goes to 0 if you have trig in there, because again, cosine of 0 is 1, it is not 0. So just be careful. All right, so that was letter A. If you were like, wow, that was a lot of work. Yeah, that was the one that was the most work. The rest of these aren't going to be quite as much here. So letter B, region R is the base of a solid. For this solid, at each x, the cross sections, this is cross sections perpendicular to the x-axis. So it's going to be a dx problem. This is unit 9 here, if you want to look back at these, all these areas and volumes. Has an area of this. Now, usually they give you a shape, like a triangle or a square or a rectangle, and you have to actually find the area of said shape. Here they just give you the area. It's fantastic. So it's going to be integral 0 to 2, because x-axis, we're using these boundaries. And then that's the area of your shape that goes in there. The area of the shape is what goes inside the integral, and they just flat out handed it to us. Again, usually they say like, oh, it's a square, and then you have to find the area of the square or whatever shape it is, but here they just gave it to you. So antiderivative, that'll be ln of x plus 3 such that 0 to 2, and then upper boundary minus lower boundary. So if you plug in 2, you get ln of 5, minus lower boundary, if you plug in 0, you get ln of 3, and that is quite literally it. So again, these don't go in order easiest to hardest, because part A was definitely harder than part B there. In fact, I would almost argue that this, it throws people off because they're like, is that it? And then you start second guessing yourself. It's almost like it's so easy that it's more difficult because you think like, should there be more? No, that's it. So, don't second guess yourself. All right, and then this last one, we're just gonna have to set it up. It says write, but do not evaluate. An integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 6. Now, whatever I write on here, I'm going to have to erase later because I'm going to have to do this with my other classes. So I'm trying to write lightly on here. 3, 4, 5, 6. All right, so here is the axis of rotation. I'm not going to try and draw a ghost shape. It would be up here because I know I can't draw this very well. Like imagine the mirror image of that up here. And your outer radius would go all the way to the edges. That would be down here at g of x. Inner radius, really small, it just goes to h of x. But there is going to be a slight gap in here. So this is your washer method. Oh, and hey guys, is this going to be dx or dy? Which one is this going to be, dx or dy? That's a question I can actually ask you guys. Type in the chat. dx or dy, guys? Fundamental question. You gotta pick one or the other. It's like we took the x-axis. Good, there we go. It's like we took the x-axis and just scooted it up a little bit. So it's going to be a dx problem, which is really good because if it was dy, we would have to rearrange both of these equations and make them x equals, like move all this stuff over, and oh my goodness, that would be horrible, right? So it is going to be dx. Set up the framework. It's going to be pi r squared minus r squared dx. So set that up. The boundaries will still be 0 to 2 because again, it's a dx problem. So from here to here, and the outer radius is going to be the upper graph minus the lower graph all the way down here. So the axis of rotation is 6. So it's going to be 6 minus g of x. And you do not have to copy over this function. You can just write g of x. Do that because it's shorter and you're less likely to do a copy error. And then the inner radius, which is really super tiny here, again, upper graph minus lower graph, it's going to be 6 minus h of x. And that's it. That's literally it. You just write that out, you get all the points. All right, so let me write down what the points were for this one. So for the first part, you get a point for setting it up. So if you even wrote that, you're going to get a point. You get a point for the antiderivatives for this part, a point for the antiderivative for this part. So you have to make sure you put that 2 over pi out front, and then a point for the answer. So that was worth 4 all by itself. Now again, if you miss this 2 over pi, you would lose this point and you would lose the answer point because it would make your answer wrong. So you'd only get 2 out of the 4 if you missed like this U substitution here. All right, part B, you get a point for setting it up and a point for the answer. I like that. That's like 2 pretty much gimme points, as long as you didn't second guess yourself. Because that's the only thing I could see happening there is going, wait, shouldn't there be more to that? Nope, there's not. And then at the end here, you get a point for, sorry, I've been talking so much yesterday and today, like losing my voice here. You get a point for pi and the boundaries. So if you even put pi and the boundaries, you get a point. And then it is 2 points for the rest of that. Again, let me look back at the scoring real quick and see how they have it worded, because they might break that into 2. Sometimes it's either 2 or 0, and they won't break it into like 1 and 1. Let me see how they have this worded here. Oh, whoops, I clicked on the wrong thing. Hold on. And I'm going to post these scoring guidelines when we finish here, and you'll be able to look through and see how they have everything worded. Oh, they did break it into 2 points. So if you had the form of the integrand correct, so if you had something squared minus something squared dx, even if you wrote garbage inside of that, you would have gotten 1 of the points. Like if you had something squared minus something squared, you would have gotten 1. And then if it was correct, the stuff that goes in the parentheses, then you would have gotten the second point. So they did break that into 2 points. It wasn't like 2 all or nothing, which is nice.